All right, we'll go ahead and get started. Welcome everyone to the second in AIA's 2030 series. If for those of you that attended back in January, we did the introduction to the 2030 commitment. And so part of our, from that, we launched into our framework of the design excellence programming. But we feel it's important enough to continue the discussion around the 2030 commitment and hopefully demystify what that takes to get your firm signed on and be working towards the goals of energy and carbon reduction through the built environment by 2030. So today, the topic is around setting targets and looking at load reduction. I'm Andrew Queenan, one of the co-chairs for our local committee on the environment. I do have a couple guest facilitators here today. You may hear my one-year-old in the background. So I'm on some double team and dad duty today. And then also we have Patrick Chopson from COTE and some of his team as well to help supplement some of what we'll see in the video today. So just to throw the learning objectives up there, we want to make sure we're understanding the design targets that are outlined in the 2030 challenge to get us moving towards a carbon neutral design. We want to look at some of the tools available to assist us as architects in setting and tracking energy targets, discuss the importance of energy end use in setting targets and achieving results, and also look at how energy modeling can be used at all stages of the design. As always, we want to thank our sponsors. We couldn't do what we do as a chapter nor a committee without their support, and so of course we thank them. So just a real quick refresh from January. So why the 2030 commitment? The built environment is responsible, the urban built environment is responsible for roughly 75% of global greenhouse emissions. Buildings alone account for 39% of that. So by being very targeted and specific on how we reduce that carbon footprint and energy use, we can make some big headway. Architects alone have a huge responsibility in helping combat climate change. So that's sort of the why. Essentially, the 2030 challenge is intended as a holistic process that your firm can adopt to target energy reduction measures. Just as a reminder, in 2020, the goal went to an 80% reduction from the 2003 CBEX baseline, and in 25 we'll jump up to a 90% as well, with the end goal being carbon neutrality by 2030, meaning no fossil fuel greenhouse emitting energy to operate our buildings. So the process in terms of the AIA's 2030 commitment is really, create an account on the Design Data Exchange, upload a commitment from your firm leadership, and then take the next couple months, really within 6 months, however long it takes you, but ideally within 6 months, create a sustainability action plan. And that's something we're targeting to continue the dialogue once we get through this series is what does that look like and how do you do it? Because the goal is to make it holistic. And then once you've done that, report at projects on the DDX using some of the tools we'll look at today. And then most importantly, that even beyond some of the scope of the 2030 commitment, I hope you're all doing anyways, but look at lessons learned on past projects, whether it's through how the design, energy utility bills compare to the energy model, and sort of track that information so that as you head into the next project, you're able to build upon your success. So with that, we'll get started with the video. Afterwards, we'll have a quick overview of the COVE tool and some of the ways that can support the targets and load reduction from Patrick and his team. Then we'll have some dialogue and discussion in Q&A following that. As I hit play on this, I think pretty much everyone is, but if you can help with the bandwidth and keep your cameras off, and once we get through the video, we can shift and turn cameras back on. So with that, we'll get started. All right. That concludes the video piece. Before I introduce Patrick to sort of add to this, some of you may be familiar with this quote, but it's from President Kennedy about going to the moon. And this quote resonates with me in terms of the magnitude of the issue we're facing regarding climate change and sort of our ability to use this not only to, of course, combat climate change, but also use it even from a different perspective of promoting innovation within practice. You know, this is sort of our moonshot. So just wanted to share that with everyone. So I guess with that, I'll hand it over to Patrick for a couple minutes to talk about COVE tool and his team and how they can help with some of the targets and benchmarking that we just got to learn a little bit about. So Patrick, take it away.
Awesome, really cool. Yeah, so I guess I can also kind of share my screen too, maybe if that works, and I can kind of share some thoughts as we go through here. But I think one of the things I think is really cool with this presentation that we all just kind of went through was the fact that, you know, they really kind of broke it down to the various different stages. Where we're actually following that in terms of for doing all these different things and managing it all in place. In the past, it was kind of difficult to actually do all these things like energy modeling, do the benchmarking, understand what all those inputs are, because, you know, kind of like the least skilled person in the office is not going to be able to do all those kinds of things. So kind of one of the things I just wanted to kind of show you guys today is that, like, if we want to do a daylight simulation, you could upload a model in this particular software to any from any different tool like SketchUp, Rhino, Revit, all those different ones, and then be able to actually run your daylight simulations, your glare models. Because one of the things I think they really pointed out in this presentation is the fact that we really need to also make sure we're considering all the different factors and not just optimizing for energy. Because if you do just energy performance, you're going to end up with a building with no windows. So we really want to make sure we have daylight, we have glare, make sure we have good views. For example, this project I actually put in Grand Rapids, I think near y'all's AIA offices. So just kind of like point out that, like, being able to understand the context of what you're doing and how it relates to the urban fabric is super important. So one thing that's really interesting too is that, like, daylight simulations or sun hours or different things like that, these can actually help influence your decision making, so that once you have everything in a good place from like daylight simulation, from, you know, from your glare standpoint, you can actually go to the energy model. And then an energy model is going to kind of be, you know, they're kind of showing the high level in the presentation, but really it comes down to you're trying to understand, like, given the fact that I've made a good building and I've tested it and I've, you know, tried to do all the things that I can to make sure that's good from a human experience, from an energy perspective, how do I move in there and really make a difference with that? So for example, here, you know, we have like our whole use energy use intensity. And, you know, that number is definitely going to be hard to understand if you don't have context for it. So one of the things that you want to do is do a benchmark. So benchmarking against the 2030 baseline, which is what the AIA is using, which is your 2003 commercial buildings database. This is what a building basically pre-code would have used in Grand Rapids 155 kBTUs per square foot. And then the target for this year, which is that 80% reduction, is your 31. So you can see that like this building here, which is using the code minimum inputs. So basically with this particular software, you can actually, the location actually sets the code. So for example, if I went, when I started this project, actually, while we were on the demo today, I actually went and created this. So basically I just put in the name of my project, the address, so it zoomed in on that spot and then actually put it there. And I picked the use type, and we're using all those kind of code minimum inputs for your IECC 2015. And then I click the education, so that pre-populates everything. And similarly, if you were doing labs or something, you couldn't use CBEX for your reporting and benchmarking, you would be using the labs 21 for that. So basically, if we're looking at energy here, you would be able to upload directly to your DDX from this tool. This is very similar to other software out there where you can upload, but you do need your DDX key for your personal key, which is a new feature that they recently added, the AIA did, to make it so it's a lot easier for like an entire firm to manage who's uploading. So it's not just like one key and you don't know who uploaded it. Now every single person can actually have their own key and things like that. And in our tool, that's going to be located under your actual, like your profile, which is going to have all that information. So kind of going back to this baseline energy though, one of the things that's kind of difficult sometimes is like knowing, like, let's say you get all the, you get a model that's run and you're like, okay, what decision do I need to make this better? And one of the things you might want to do is you could generate a report or something like that. And I'll show you guys that as well. And then the last part of it that I always like to point out too is that you can achieve these really aggressive targets that we're all talking about. And you can, if you use some kind of like cost optimization. So this is kind of an example of if we took our building that we ran the energy for, then we could run different alternatives for like the envelope or for the roof or the HVAC, different things like that. And we could actually come up with, maybe if we use different kinds of lighting power density, like they talked about, using LEDs instead of the T8s, maybe it's costs a little bit more per square foot, or maybe not, it just kind of depends. Or maybe we're going to use like some other alternatives, and then we could actually rerun this optimization and figure out the best combination of cost and energy. And each one of these blue lines basically represents an optimized bundle, so something that's better than baseline. So we can actually achieve in this project, and with very few options. So I just kind of went with the defaults. You could get a 37% energy savings for about $358,000 more. If I add more alternatives to like different HVAC systems, maybe if I add some heat recovery, things like that, I could actually potentially have a really optimized building that could actually cost less than code minimum. So that's kind of some. Just wanted to show you guys really quickly. Of course, if you guys are using this on your actual project, you can always chat with us and ask us all kinds of questions and things like that as well. So Andrew, I didn't know if there was anything specific other than kind of like how to do your benchmarking and things like that that you want to talk about, but those are some of the kind of basic thoughts that I thought, just kind of a quick run through to show that there are tools out there that do exist that can do all these things, and it's fairly easy to implement if you get trained on it. It's not probably more than like an hour to learn how to use a software like this.
No, I think that was great. I think we can open it up to questions and dialogue. I know the part of my connection with Patrick is my firm is a subscriber to Cove Tool, and even this morning I was updating some projects and checking some things, and we made the decision to go this route because as we looked at some things, it was an easy and intuitive tool to support our goal of pursuing the 2030 commitment, and definitely when you add in the benefits like daylight analysis and some of these other features that go beyond energy and get into enhancing architectural design. That was a huge factor for us. So yeah, I guess from there, any questions?
And and definitely too, if, you know, if there's questions that you guys are thinking of, a lot of times people are asking themselves, like, you know, will clients actually go for this kind of thing? And one of the things that's really interesting is right now, like all the big investment banks out there, like Goldman Sachs or big equity, private equity people like, was it, you know, there's a lot of really large corporations that are all, and investment groups are all focusing on their carbon. So a lot of times, like these types of workflows are not optional now. For many clients, they're actually required to report that information.
How do you recommend trying to ask a leading question with an example? I guess to sort of build on a bit of what you were saying, I know that that's something we've been doing with our clients is even, you know, these daylight studies. It's built off our Revit model and easy and intuitive enough to use that we're bringing these floor plans to meetings to sort of, it sounds a little harsh to say justify design decisions, but we're finding a lot of good reaction to it. And so I know some of the questions we've had at our earlier 2030 event is how do you add one more thing? And you know, we're all so busy, and I think that's what's nice with at least this tool in particular is if you're in Revit, it's built off that platform, or it utilizes that platform in addition to things like SketchUp and Rhino. But it allows you as the architect to support your decision making a little more than, you know, obviously some clients might care purely about aesthetics and others might still not really care about performance, but when they actually see that you've done an analysis and justify the design decisions you're making, that's an experience we've had. We had a client like, okay, yeah, like I didn't really want to put more glass in this building, but now that you've approached it in a way of like, it was an office building and enhancing the occupant health and well-being and justifying it with that daylight analysis, they were just like, wow, we hadn't thought about this. Thanks for sharing it. And it opens the doors to those deeper conversations like the video talked about, like, okay, you know, you've maybe tightened up your floor plate to be a little more narrow, whether it was for passive ventilation or daylight, but now you can start to then go down the rabbit hole of other topics. So
yeah, and I think like it's better if you just emphasize with a client that this is how we work and this is
yes,
how the best architects in the world do it. And if you're not doing it, it doesn't, like, we want to justify with data why we're making decisions, because we're following a more you know, process driven workflow. And a lot, especially ones who are more, you know, not your designerly types, you know, when they see a daylight model and they see that their office has sufficient daylight, they're like, you know what, I do sit in front of my desk at home and I'm looking forward to when I get back in the office, like having daylight there and not sitting in a cubicle. And when you can show that to them, you know, you know, whoever's in charge, you know, like, you know, the CEO of the company, he's like, you know, if my people are going to be more productive, you know, I don't care about if I'm, you know, the necessarily the energy thing, because, you know, like here in Georgia, you know, there's still people that don't think climate change is real and things like that. So you know, sometimes it's really good if you can just talk about the cost savings and the performance, because that's not a conversation that's political. That's a conversation that's like very much focused on, like, you know, that kind of green that you can hold. And that's the kind of things that I think are way more effective when you can communicate to people that we made this decision. Here's the justification behind it. You know, a lot of times you can do cooler buildings if you can show that the daylight and performance actually work better.
Patrick, this is Dennis Beck, and I have a question for you. With
Mhm.
Cove Tool here, it's the first I've seen it. We talked in the video we watched, it talked about making different types of decisions from schematic design to design development construction. Is this tool capable of doing all of those types of analysis? I mean, is it more geared towards schematic, or can you do very detailed modeling that gets into the specifics that we talked about for construction drawings?
Right, right. So one of the things we just recently introduced was the ability to send this model to a compliance level energy simulation through OpenStudio. And so typically the best thing to do is to invite your mechanical engineers to a project in this tool or any project that you're working on. Just making sure that those engineers are involved early. One thing that's really good is if the engineer can take your model from here and not have to remodel, it significantly reduces the amount of time it takes them to get you feedback. So we do recommend that if you're going to use this tool in the later stages of the project, you know, having an engineer that can check all this information, because it is automated, but you know, you want to check for your specific location. So yeah, you could use this in later stages of the project, but you would have to have other people checking your work. More so, the cost optimization is probably the part of the tool that you would use more late design all the way to construction documents, just because it's going to allow you to keep, every time you get a cost estimate, to rerun an optimization using machine learning to figure out like what's the best combination of things in terms of lead points or payback years or cost premiums, things like that. So I would recommend like just getting more people involved early, the more likely it is that you'll actually make it happen. Um, Otherwise, yeah, this tool would not, just on its own, if you were just the architect, you might not know what the changes to the inputs you would need later on. But through a schematic to like conceptual level, this tool's automated inputs will be correct for whatever project you're working on.
Thank you.
Mm-hmm.
And I think what I'd add is it's, as an architect and using this, it's a great way to engage in that dialogue. You know, in larger firm practice, I traditionally had mechanical engineers on staff with me, and they were just handling the energy model. And it was sort of up to me if I asked about it. And everyone, you know, they'd ask questions like, hey, what's your R value in your walls? And, you know, some of those inputs for the compliance level software like Patrick's talking about. But that's what's nice here is I feel like it's at a level where I can engage with it enough to get heading in a direction, to set a good baseline, really. You know, work at that early stage, get some goals in place, and know, you know, like the example Patrick has up right now, like this building's a heating load dominant building. So that right away can tell me, hey, there are things I need to do in the envelope, but there's also discussions I need to have with the engineering team about what system approach we're going to take to try to get that lesson. So,
And also too, just like, you know, when you're first starting out, you have different specifications for different products. Like these little stoplight things here kind of tell you next to, like, if that's a bad input, it's red. So we can see that if I wanted to make an improvement to my project, I can maybe change this to a more expensive glass, like a 0.22 U value, and then it turns green. And then if I recalculate, since my building is mostly glass and my heating load's really high, and I know that I'm in Grand Rapids, maybe you know, bumping up the spec on that. And then now I got to 17. Now I'm getting really close to that 2030 target just from changing that one parameter. So it can kind of be, and I got 3 lead points. So it can be a really good way to kind of like iteratively work through things before you even talk to the engineering team. You've actually thought through it yourself and you see what are the things that are driving the load. Like maybe I can look at these, we have these personalized recommendations about your project that tell you what's contributing to your EUI. And you can kind of look at that and say like, okay, what changes should I make? It tells you where to go edit stuff. So you can kind of like think about, like, does that make sense for my project? Things like that. Or maybe just looking at passive strategies. If you click on the report button, it actually has all the 2030 palette options that you might want to consider, like passive strategies. It actually has them figured out for your project location. What are the things you might want to try? And then if you click on it, you can go to the 2030 website for that particular strategy, where it'll have a lot of really good case studies and ideas on what you could do in terms of like tools and resources, other tools out there you could use, or other books that you could read, or websites. And then you can look at things like maybe the your psychometric chart that tells you which passive strategies lead to maximum benefit. So we can see that internal heat gain is really what we want to maximize. So letting the maximum sun in on the south facing glass is going to be a really great strategy, maybe for Grand Rapids, things like that.
That's a, I guess, good segue into sort of the final piece of this. And if anyone does have questions, feel free to pop in with them. But I guess just some concluding thoughts. I guess first, I would put the challenge out to everyone, and I'll continue to do this as we go through this series. Are you going to sign on to the 2030 commitment? If you do, please let us know. Currently, there are 3 firms in Grand Rapids that are signed on. We'd love to see, a good representation of our membership sign on and begin taking action on this and tracking this data. And of course, the Committee on the Environment is here to help with that in any way we can. So feel free to reach out to Matt Van Sweden or myself, or if I know there's a few members of our committee on the call as well. My challenge to you would be, within your firms, are you asking leadership and other staff members? I want to also share some other slides. Patrick mentioned the 2030 palette, which is a good tool to at least get a high level overview of some of the strategies that you could implement early. Within that, one of the newer in the last couple of years is the Carbon Smart Materials palette. So that's great for looking at the embodied carbon impact of different materials and strategies. So, concrete is a huge carbon intensive product that's in all our buildings. So that's a big strategy of where we can cut quite a bit of the embodied carbon. And then there's, of course, some others that you may have seen come out recently. The primer on renewable energy, the Architect's Guide to Building Performance, and then as it relates to benchmarking, the Zero tool is also a pretty great and easy tool that reads that CBEX data and can at least, at a minimum, you can go there, input your building location and square footage and use type, and it'll say, here's, a targeted EUI to be net zero, and here's targeted for the 2030 commitment. So let me just check. I don't see, let me check chat one more time here. Where'd it go? While I'm trying to get the chat up, next month, so next month, tentatively June 29th, we're sort of working through some scheduling things, but we'll do the next session in the 2030 series, Accentuate the Positive Climate Responsive Design. So I look forward to seeing everyone there. And of course, thanks, Patrick, to you and your team for joining us today. And yeah, we'll see you next month, everyone. Thanks.
Yeah, thanks for having me on.
Yeah.
Thanks, Andrew. Thanks, Patrick.